Alright, so welcome back to the OneClass channel. Again, my name is Joey. I'm going to be your math teacher for this session. So what we're doing here at OneClass is we're going through this kind of journey of verifying solutions to frequently asked problems in both the mathematics subject area and also in the chemistry subject area. So particularly, it's questions going from basically in the secondary level as also in the university and the college level as well. So specifically what we're focused on today is we're going to do math, and we're going to do problems basically that we would typically see ranging from anywhere between grade 9 all the way up to grade 12 calculus. So about 10 problems for us today, and we'll go through those questions and solutions together. So my name is Joey. I'm currently an Ontario school educator, and my teachable subjects are mathematics and chemistry as well. So let's get started on these problems for today. So let's see. I have my first question is asking us, what does tan pi over 2 equal? So there's a lot of ways to approach this problem here. So I want tan pi over 2 equals what? I want to find the exact value of this guy here. So there's kind of two ways to approach this. You can approach this using using the unit circle, like what they did here in this solution, or you can kind of approach this using like special triangles, because pi over 2 is indeed 90 degrees. What we can do is we can actually use a triangle, and we can figure out what the angles are. So let me just draw out a triangle for you, and actually we'll go over this kind of unit circle. This unit circle first, and then we'll figure out what it means for tangent here. So let's see. So what we have here is, so it says all trigonometric ratios can be found using the unit circle. So they have a unit circle here. So let me zoom in for you, because this is a pretty good diagram here. So you have a unit circle, you have some type of x here, so some type of x here, and I'll redraw this here. So some type of x and some type of y, and we know that this length here is 1, and we want to look at this theta here, right? So basically, when we look at pi over 2 here, pi over 2 is going to be pi over 2 is at this kind of it makes a right angle here. This here is 90 degrees, so we're basically extending theta all the way to this right angle here. So it says here, as you can see, that the pi over 2 is along the upside of the y-axis. So there's the cosine value is 0 there. And you know that tangent is the ratio of sine to cosine, right? So in this case here, we know that tangent equals, tangent pi over 2 is simply just sine pi over 2 divided by cosine pi over 2. This is a simple quotient identity that we should know by now. In trigonometry, so tangent is simply sine over cosine, and we know that in this case here, so in this case sine pi over 2, we know that this here is pi over 2, so we know that sine pi over 2 is actually 1, right? Because again, if I maximize this angle here, again it's opposite over the hypotenuse, so we have some type of y here over 1, so we know that sine pi over 2 here is indeed 1, right? So we know sine pi over 2 is 1. However, cos pi over 2, if we take the adjacent here over the hypotenuse here, if we maximize this angle here to pi over 2, we're going to realize that cosine here is 0. So it's going to be 1 divided by 0. And this here is no, right? We don't want to divide by 0. Dividing by 0 is no good. By 0 means that it is undefined. So in this case here, tangent pi over 2 is 1 divided by 0, so therefore it will be an undefined kind of value. So this is here as our answer. The pi over 2 is indeed undefined. So this is the correct answer. What we can do is we can also actually solve this problem using a graph. So if I were to graph tangent, I can start from 0 here. I have pi over 2. This is pi, 3 pi over 2, and 2 pi. 2 pi. You realize that tangent of 0 is 0 here, and this actually goes it kind of goes like this kind of this like cubic function, like so. It kind of starts at pi over 2 and then kind of goes towards 0, and then makes his way like this. And there's a horizontal asymptote vertical asymptote at basically pi over 2 and 3 pi over 2, like so. So this is kind of the graph of this here. You can say it's y of tangent of x here. And basically at every pi over 2, at every odd number of pi over 2 here, you would get a asymptote, and every even pi here, or every, not even pi, but every n pi, you would get 0, and every n pi over 2, you would get an undefined value. So this is also, so taking tangent of pi over 2, this here is an asymptote, so therefore it is undefined. So you can say, you can use the graph to prove that pi over 2 is undefined. So there are a lot of ways to figure this out, or you can just simply use sine over cosine here. We know sine of pi over 2 is 1, and cos pi over 2 is 0, so therefore it's 1 divided by 0, so there's undefined. So both ways work. One is algebraically, one is graphically. Both of them work to figure out that tan pi over 2 is indeed undefined. So this here solution is correct. Okay. It says find all the fourth roots. And I think I've done this problem before, but we can do it again here. Find all the fourth roots of 625 over 2401. And this is the real fourth root, right? So I want the real fourth roots here of 625 over 2401. So basically I want to find this guy here. So fourth root of 625 over 2401. And how do we solve that? Well, I know that in this case here, you can say that you can split this up into two parts. You can say it's 625 over the fourth root of 2401. And then what we can do here is we can solve for the numerator and the denominator first. So the numerator here is 625. So logically, I'm going to check with 5, right? Because I'm using the prime factorizations here. So in this case, because it ends in 5, I'm going to guess that 5 here is the fourth root. So I'm going to take 5 to the power 4 and see if that equals 625. 5 times 5 is 25 times 25 here, which equals 625. So this here is good. So this means I have 5 at the top, because if 5 to the power 4 is 625, therefore fourth root of 625 would equal 5 here. So this is my logic here. And then with 2401, this is a bit more tricky. With 2401, so we have 2401. If I add the digits together, let me see if it's divisible by 3. So 2 plus 4 is 6, plus 1 is 7. So it's not divisible by 3. So, and it's not an even number as well. So it can't be 1, 2, 3, it can't be 4, it can't be 5, it can't be 6 as well. So it has to be 7. Remember, it can't be an even number, and it can't be 3 here, and it can't be 5. So therefore, I'm going to check 7. So 7 to the power 4 is 7 times 7 times 7 times 7. This is 49 times 49, which will equal 2401. And you can check that if you wanted to. But I know that now, because of this relationship, fourth root of 2401 equals 7. So therefore, this is simply 5 over 7 here. So 5 over 7 is great, right? And every time I square root something, I'm going to have to do the plus or minus or something like that. So I'm going to have to do plus or minus 5, 7. And also, if I were to consider the complex roots, I would also have to do 5 over 7, and this would be I as well. So I would put an I here and then put plus or minus as well. However, we only care about the real roots, right? So again, this here is the real, this here is complex. So I can say so therefore the answers are going to be plus positive 5 over 7 and negative 5 over 7. And these two are my answers for all the fourth roots of all the real fourth roots of 625 here. So therefore, plus 5 over 7 and negative 5 over 7 is the correct answer. So the solution is correct. We're basically using trial and error to figure out the fourth root first, and then we realize that if we take the square root, we're going to get plus or minus basically that number as well. And then if you want to find the complex roots, you simply just add the I here, because again, if we do the complex roots here, this would also equal 625, or the fourth root of 625 here. So solution here is correct. Let's do number 3. Okay, so I can click this link. Let me try clicking this link here because I don't think I see the entire question. I have to zoom out. There we go. Okay, so it's saying number 3 is asking if f of x is 27. I don't know what that degree sign is, so maybe I'll actually have to download this file to see what that degree sign means. So give me a second. Let me download the file. Hopefully it brings this up. There we go. Oh, okay, so that's a much bigger question than needed here. Oh, it's 2/7. Okay, so that formatting is off here. So so it's asking us if f of x equals, this is 2x cubed minus 5x squared plus 3x minus 7 all over 7x squared plus 2x plus 1300, then, and then we have options, right? So so we have the limit as x approaches. I don't even see this. Is it positive infinity or negative infinity? I can't even see this. I think they're all negative infinities. Okay. The resolution is just really bad here. So negative infinity of f of x equals 2/7. Either equals infinity, either equals 0, or negative infinity, or none of these. None of these. And these guys are all the same. They're all approaching negative infinity here. Okay, so how would I solve this problem? So, this is A, B, C, and D. So if I want to take the limit of this function here, what I want to do first is you can think of it as, you can either sub in a big negative number to solve for our limit here, or if we see what we're doing here, we can actually use kind of our advanced functions knowledge to kind of help us kind of get rid of these terms first. So what I would do here is I would actually factor both the top and the bottom parts to see if some of these guys are factorable. So let me just see I'm going to do the denominator first because we have a quadratic here. So let's see here. In this case, our denominator is not factorable, which is unfortunate. But what we can do with this here is we can actually use long division, right? We have something divided by something. So let's use long division and figure this out. So I'm going to have to recopy this. Yeah, I'm going to have to recopy this into a long division problem. And we'll see if they divide out nicely. So we have 7x squared plus 2x plus 1300. And we're basically using long division to help to see whether or not it clears up this function here. So it's 2x cubed minus 5x squared plus 3x minus 7. So we're using this concept of long division. So let's see. We want 7 here. So in this case, I want to see, I want this number to be, I want this times this has to equal, I want to cancel this x cubed term. So I'm going to put 7/2. 7/2x. Because 7/2, or actually, sorry, it's 2/7, not 7/2 here. X here, because 7 times 2/7 would give me a value of 2, and that's what I want here. So I'm going to multiply everything by 2/7x. So this would give me 2x cubed, obviously. And we get 2 times 2/7, which is 4/7x squared. And then 2/7 times 1300. So let me just use my calculator here. 2/7 times 1300. I don't think this is going to go evenly. Yeah, it's not going to go nicely. So this is going to be plus 2600/7x here. I'm going to do this division, and I hope this helps out. So this cancels out here. I have so I have 3x minus this guy here. So 3 minus that number would give me not a great number, actually. I get negative -2579 over 7x, and then -5 plus, basically plus 4 over 7 here. So -5 plus 4 over 7. It's going to be -31 over 7x squared. And then again, I can do the I can do another one, right? So 7 times what number would give me -31 over 7? Well, I would have to multiply this by 7 over, I would have to multiply this by a positive number here. So this is positive. This would be, let's see, I want a positive number here. Or no, I want a negative number here to get me a negative number here. So this would add to 0 here. So I want negative number at the top. So I want 7. Basically, I want -31 over 7 here. So I would put -31 over 7. If I multiply both of these guys here, or actually I should, let's see, let me do this math here. So this is 7 times what number would give me -31 over 7. So I want all of these guys over 7. So I can say that this here is x, 7x here. I can move the x to the other, move 7 to the other side. So it's whatever -31 over 7 divided by 7 here, which is -31 over 49, which is a really, really weird number here. X. I have a feeling this is not going to work out, but we will try this regardless. Times 7 would give me -1 over 37, which is good. So this would give me -31 over 7x squared. And this is going to cancel to 0, obviously. And then I have negative, or actually, let me bring the -7 down here. I have -31 times, or -31 over 49 times 2, which is going to give me -62 over 49x. And then finally, I have this guy would be, let's see, -30, sorry, this here is x squared. This is x squared, which is good. This here is, I'm multiplying it by 2 here. Oh no, this is simply just x here, sorry. So this here would be x here. And then -31 over 49 times 1300. I don't think this is going to subtract nicely. I have 40,300 over 49. So these two guys cancel out. I'm left with, let's see, -2579 over 7 plus 62. Let's see, 62 over 49, which gives me a really whack number, 17991 over 49. And this is -7 minus 40300 over 49. And this is -40643 over 49. And I have some number here, which should give me, actually this is our remainder here, right? Because I canceled the x here, and I simply only need, yeah, this here is my remainder here, which is actually no good because this doesn't divide out evenly, basically. So basically all this work is obsolete here because I can't divide out. So basically what we want to do in this kind of question, I'm going to have to revert back because I wanted to try to simplify some of these guys here, but they're not going to simplify. So they're saying here the answer is D, but again, they don't really show any work here. So let's see what you would get here. So again, it's saying if I want to sub in a limit to -infinity, right? So I'm going to see if I can do the cubic formula for the top part to see if I get some type of factor here. And I do get some type of factor, but I have I have 2 complex roots and 1 real root. So in this case, it doesn't really help us. So what we can do is we can simply just sub in -infinity in this case into their function here. So let's sub that in here. So what would I get? we'll get 2 times, I guess, negative infinity cubed, which is simply just negative infinity, minus, or actually, what I can do is I can partially factor out the x's here. So some of these x's kind of cancel out before I kind of do this here. So let me factor out x here, and I get 2, I would get 2x squared minus 5x plus 3, and this would be minus 7 over x. And then I can factor out this x again here from this side here, which will get me 7x plus 2 plus 1300 over x here. And this would help me because these guys here, these x's cancel out, right? So we get 2x squared minus 5x. Oh. So this might put me on the right track here. Minus 5x plus 3 minus 7 over x all over 7x plus 2 plus 1300 over x here. And what we can do with this guy here is that we could either sub it in negative infinity. If we sub in negative infinity for this value here, because again, these guys are going to cancel out, right? So what I could do is I could have actually put I could actually factor this again. I could have actually took out x squared in x squared. So maybe I'll do that again. I'll factor out another x here. So we get negative 5 plus 3 over x minus 7x squared. And I'm factoring out another x, so I get 7 plus 2 over x plus 1300 x squared. And this might help us actually with our limit, which is now 2x minus 5 plus 3 over x minus 7 over x squared divided by 7 plus 2 over x plus 2 over x plus 1300 x squared. Oh no, sorry, minus no, plus 1300 x squared, sorry. Yeah, that's good. These guys are separate. Okay, so what we have here is now we have this function here. What we're going to do is we're going to sub in negative infinity to as our x value here. So if we sub in negative infinity here, we're going to realize that 3 divided by, if you think about it, 3 divided by a really, really, really big negative number, like let's say like 100 million or something, is going to be basically 0. And what that means is if I subbed in 3 divided by negative like 100 trillion, for example, I get basically negative 3 times like 10 to the like negative something, right? It's practically 0. The number is so small that we don't really care about it. So basically these guys here are going to equal 0. This guy here equals 0 as well. This here equals 0, and this here equals 0. So therefore you get so this here you get 2x. So this is now subbing in, right? So I subbed in the limit here. So I'm finding the limit as x approaches negative infinity. So now I subbed in negative infinity here. So I would have, again, 2 times, I guess, negative infinity minus 5 all over 7. And again, if negative infinity is at the top here, it's going to mean that negative infinity is going to basically reign over. So in this case here, this is simply just equal to negative infinity. So the answer here is D. So this is why this works here. So this answer here is D, and this solution here is correct. So again, what I did with this problem here is I tried to again factor this. So factor this out first. So again, I used the quadratic formula. It didn't work out. The cubic formula didn't work as well. I tried to use long division. It didn't work out. So I simply had to use I had to common factor some of these terms out for us to figure out a solution. So this solution is correct, but they didn't provide any analysis. So I'm going to see if I can write this all down into this box here. So I'm going to say that. So I have f of x equals, this was 2x cubed minus 5x squared. And again, the formatting of this problem was off first, so I'm going to rewrite this solution here. Divided by 7x squared plus 2x plus 1300. So I can also say that f of x now equals, I'm going to factor out, I'm basically factoring out x squared from both of these guys here. Factor x squared. So I get 2x here minus 5 plus 3 over x, and then minus 7 over x squared, all divided by x squared, factored out here. So I get 7 plus 2 over x plus 1300 over x squared here. And again, the x squares cancel out, so I'm left with here with it's going to equal simply just 2x minus 5. I should put brackets here actually. I'm left with 2x minus 5 plus 3 over x minus 7 over x squared divided by this here. I'm left with 7 plus 2 over x plus 1300 over x squared. Now we take the limit as x approaches negative infinity. Therefore, we have f over x equals, it would simply be negative infinity or I guess I would have 2 times negative infinity minus 5 divided by 7. Therefore, the limit as x approaches infinity or negative infinity of the given function is negative infinity. I should wrote here lim as x approaches negative infinity of f of x. It's really hard to do this formatting on this, so therefore it's negative infinity. It's really hard to do the formatting here. So therefore, as the limit as x approaches infinity, as approaches negative infinity of the function is negative infinity, so the answer is D. So the solution here is correct, but they did not give an analysis. So I'm going to say solution is correct, but no given analysis here. Okay. So that's number 3. Let's look at number 4. So asking us definition slope-intercept form. So definition of a slope-intercept form, you can think of it as equals y equals mx plus b. And that's going to be our slope-intercept form. Is simply just y equals mx plus b. I like b here. I don't like c personally. But what we can do is within this here, we have this here is y. So we have x and our y points. So these are x and y coordinates. Or you can say points on the line, on a given line. We have here, it's our m. So m would equal our slope. And we can calculate that using basically either rise over run, or you can calculate it given 2 points. You can say y2 minus y1 over x2 minus x1. And then we have b here. B here is our y-intercept. So if we have some type of equation here, and let me give you an example here. So if we have some type of equation, we can say that, say y equals 3x plus 2. This here would be a given line, right? So we can say that the slope here is 3, the y-intercept is 2. And what we can do is we can actually plot this into our graph, right? We can graph this using slope-intercept form. It's actually a very, very powerful tool. So what we can do is we can say that the y-intercept is 2, so we can say this is 1, this is 2, so this point is 2. So we know that we have a point in the line, and we know the slope is 3, right? So if rise over run is 3, we can say it's going to, this is going to increase by 3 up, and then goes right by 1. So we can say that it goes up by 3, so maybe up to 5 here, and then it goes to right by 1 here. Oh. Right by 1 here. So we can say that this here is a line. Given these 2 points, we can say we can create a line here. And it says maybe like here, close enough. And we can say that this here is our y equals 3x plus 2. And this here is our this here is the definition of the slope-intercept form. It provides us information about our x and y coordinates, so any points at the plane will lie along the x and y, and our m here is our slope, again rise over 1 or run, or y2 minus y1 over x2 minus x1, and b here is our y-intercept, so when it crosses the y-axis. So the solution here is correct. They give you a different formula, which is fine, but it's exactly the same thing. So you have a slope, which is m, you have y-intercept, which is, so you can plot out your point here, which is great. So solution here is correct. Good analysis. Okay, this is number 4. Let's look at number 5. It's asking us, I want the complete factorization and factorize. So I want to factor x cubed plus 4x squared plus 5x plus 5x plus 2. Factor x cubed plus 4x squared plus 5x plus 2. So how do I factor this? So again, I don't have a quadratic here. This here is a cubic function. So I can't use the quadratic formula in this case here. So what I have to do is I actually have to use something called the factor theorem. Factor theorem. And the factor theorem basically just states if I take basically this a value, which is, you can think of this as this general formula, which is ax cubed plus bx squared plus cx plus d. And you can think of it as the factor theorem is basically a times d here, which is simply just 1 times 2, which is 2 here. And all the factors of 2 plus or minus those factors would give you, if you plug in those x values, and if it gave you 0 at the end, if this equation here equals 0, then it would be a factor, right? So this is mostly just trial and error using your calculator to figure this out. So I want the factors of 1 times 2 here, which is simply just positive 2, and the factors that are 1 and 2, and it's plus or minus 1 and plus or minus 2, right? So plus or minus 1, plus or minus 2. And I care about those factors, and I basically have to use my calculator, and I would plug in basically, I would start with 1. I would have x here would be 1. So if so I can say here if x equals 1, then f of x, or I'm going to say that here this function is f of x, is equal to, so 1 cubed plus 4 times 1 squared plus 5 times 1 plus 2, which would give me 12. So in this case, it would not give me 0. So x equals 1 is not a factor. So let me try, what if x equals negative 1? Then f of x, again, I'm looking for a 0, right? So I'm basically going to my calculator, I'm modifying all the x values to negative 1 instead. And negative 1 indeed equals 0. So in this case, if negative 1 gives me a 0 here, therefore I know my factor. So you can say, therefore, x equals negative 1 is a factor. So you can say that x plus 1 is a factor as well. Remember, you flip the sign if you want to put it into this kind of format here. So remember, x plus 1 equals 0, right? So this is a factor. So if we know a factor here, we can simply use either factor theorem, or we could use long division or synthetic division to figure out the rest of our factors here. So as long as we get the first one here, so if x plus 1 is a factor, then what we can do is, I like long division, so I'll use long division in this case to figure out what the other two factors are. So x plus 1, so x times what value would give me cubed, x times x squared would give me that value. So x cubed, 1 times x squared is simply x squared. Subtracting both of them, 4 minus 1 here is 3x squared. These two guys cancel out. I bring down the 5x here. I do the exact same thing. X times what value would give me x squared? Well, I would need a 3x, right? To get 3x squared, I want to cancel out this term here. 3x times 1 is simply just 3x. I subtract both of these guys here. I would get these two guys cancel out. 5 minus 3 here is 2, so I have 2x. Bring down the 2. X times what value would give me 2x? I simply need a 2 here to finish this problem off. Plus 2 here. And this here would be 2 times x here is 2x. 2 times 1 here is 2. And this would give me a remainder of 0, which is perfect. So therefore, I can say that these two guys are also a factor, right? So I can say that therefore x plus 1 and x squared plus 3x plus 2 would equal x cubed plus 4x squared plus 5x plus 2, right? And what we can do now, we can say that if we have our x plus 1 here and we have a quadratic function, we can simply just factor this guy out, right? So we can basically factor this here as a factor by inspection, and I can say x plus 1. Again, I can take a and c here, and what two factors would give me 3? Well, 2 plus 1 here equals 3. So therefore, it's 2 plus 1, and then, or x plus 1 and x plus 2. And this here would equal this guy, so I can say therefore, it's x plus 1 squared and x plus 2 is the factored version of this. So this here is our answer. And as you can see, this here is the correct answer as well. They have x plus 1, and x plus 2. I wrote it like this, but it's also the correct answer as well. So the solution is correct. Good analysis. Okay, that was number 5. Okay, let's look at 6. The fourth power of an integer is x. X is between 100 and 600. What is x? Okay, so this is number 6. Okay, so I want the fourth power of an integer is x, right? And x is between 100 to 600. So first I'm going to say, or let me write this down first. I'm going to say the fourth power of an integer is x. And x is between 100 and 600. What is x? So first I'm going to say let n equal the integer. So basically I can say that the fourth power of this integer, so n to the 4 would equal x. And x is between 100 and 600, right? And it has to be an integer. So this has to be a positive. It's basically a positive integer. And we basically do kind of a guess and check here. So n to the power 4 and x is between 100 to 600. So we know that x here has to be between 100 and 600. So we can basically say if n here equals 4, then we can say n to the 4 equals x, and x has to be between these guys. What we can do is we can just simply substitute. We can guess and check some n's, right? So we can say trial and error, or you can say guess and check. So basically, you sub in n. What if? So if n equals 1. Therefore, 1 to the power of 4 would equal 1. And it's not there, and it's not between 100 and 600, so this guy is obviously not good. And then we keep trying numbers, right? So if n here equals 2, then 2 to the power of 4 here is simply just 2 times 2 times 2 times 2, right? Which is going to be 2 times 2 times 2 times 2 is 16. Which is also not true because these are not, it's not between 100 to 600. So I'm going to try 3. If n here equals 3, then 3 to the power of 4 is going to equal 3 times 3 times 3 times 3, right? This would be 9 times 9, which is simply just 81. And this here is not between both of those numbers, so therefore this answer is also not correct. And we basically just keep checking, right? We basically increase our n value by 1 every time. And we check. We have 4 times 4 times 4 times 4, which is 16 times 16. This is going to give me a value of 256. So n equals 4 does satisfy this equation here because it's between 100 and 600, which is great. But let me check n equals 5, and let's see if this one figures itself out. 4 to the power of 5 is simply 5 times 5 times 5 times 5, which is going to be 25 times 25. And this here is 25 times 25, I believe, is 625. And this here falls outside my range of 100 to 600. So therefore, this guy is false, and this one here is true. So therefore, my integer, my n here, so you can say that therefore, just in red here, so therefore, n equals 4. So you can say 4 to the power 4 here is going to be 256. So therefore, x would equal 256. And this here is my answer for this problem. So again, the value is 256, and they did exactly the same thing where they guessed and checked, right? So this is false, false, false. 256 here is true, and 625 is false. So they didn't realize that n here would equal 4, so therefore x here would be 256. So the solution is correct. Good analysis. Okay, that's number 6. Let's look at 7 here. I think they wanted to write 4 1/3. 4 1/3 divided by 1 over 16. Is that what they, or 1 over 6, sorry. 1/16? Yeah, I think they 1/16 here. So I think they wanted to just divide these two fractions. So I have 4 1/5 and 1 over 1/16. Or sorry, 4 1/3, not fifths here. So basically, if I'm dividing two mixed fractions, what I want to do is I want to convert them into improper fractions. So I have mixed fractions. Sorry, that was really bad. Mixed fractions, and I want to convert them into improper fractions. So if I were to do this conversion, again, I'm doing 4 times 3 plus 1, right? So 4 times 3 is 12, plus 1 is 13. So 13 over 3. I'm still doing the division operation. 1 times 6 plus the numerator. So 1 times 6 here is 6, plus 1 would give me 7 over 6. And what we can do is when we're dividing fractions, what we can do is we can simply just change this to a multiplication question by basically multiplying by the reciprocal. So we have 13 over 3. I'm changing my operation to multiply, and I'm simply going to flip the second fraction. So instead of 7 over 6, this would be now 6 over 7. And again, this question now becomes really easy, right? So I can simply just cross this guy out and divide these guys by 3. So I would have 26. 13 times 2 is 26 over 1 times 7 is 7. So I have 26 over 7. Or you can simply rewrite this as a mixed fraction by simply taking 7 times what number gives me closest to 26? Well, 7 times 3 gives me 21, which is close to 26, and I have a remainder of 5, which is simply 5 over 7. So these are my answers here. So 26 over 7, or 3 and 5/6. So this solution here is correct. Good analysis. Number 7, 3 more questions for the day. Number 8. I have 168 centimeters in feet and inches, and I think I've done this problem before as well. We can do this again. What we have to do is, again, I have this here is in centimeters is in the metric system, and feet and inches is in the imperial. So I have to figure out a conversion factor for us to figure out those guys here, and I'm measuring in length. So I have to figure out some type of conversion factors for both of these systems here. So I want to convert centimeters into inches first. So what I would do is, I know that 1 centimeter here, the conversion factor for this is 0.393701 inches. So if I were to convert this, I simply have 168 centimeters. I'm going to multiply it by the conversion factor, right? And again, in 1 centimeter, which is going to be the bottom, I have 0.393701 inches here. These centimeters are going to cancel out. So I'm left with whatever 168 times the conversion factor. So 168 times 0.393101, or 701, sorry. 701, which will give me 66.14. 66.14 inches. And what we can do with this is we can convert this into feet and inches, right? So I know now, because I'm in both the empirical system, I know that 1 foot would equal 12 inches. So knowing this conversion, I can figure out this conversion as well, right? So I can say that 66.14 inches times in 1 inch, or in 1 foot, I want to convert here, I have 12 inches, right? So I can say 1 foot here, I have 12 inches. So these inches again cancel out. I get 66.14 times 1 over 12, or I can say 66.14 divided by 12 here, which is going to equal 5.5 something, 5.51 feet. So instead of saying this, if I want my answer in feet and in inches, I can say that I have 5.51 feet, or I can say 66 inches, or if I want to say foot and inches, what I can do is I know that 5 feet is 60 inches, right? So 5 feet here is equal to 60 inches, because I know that 1 foot is 12 inches, right? I simply just multiply both of these sides by 5 to get me the equation on top. So I can say that therefore 168 cm is going to equal 5 feet, and whatever is left over. So 66.14 minus 60 would be 6.14 inches. So 5 foot, 6.14 inches. And this here is the answer for this problem. So again, what they did here was they did the inches, which is correct, and they did feet, which is also correct. So this solution is correct. And then I took a step further and I calculated in feet and inches. So the solution is correct. Unit analysis can also express 168 centimeters as 5 foot and 6.14 inches. So this is a great solution. And finally, or no, this is the second last question actually. I think this is question 9 now. 1, 2, 5, 6, 7, 8, 9, 10 problems here. I believe I have 10 problems, hopefully. Let's see, this is number 9 here. I want the square root of 24. Square root of 24. So all I'm going to have to do is I'm going to use prime factorization, right? So I have root 24. I want to break this 24 down into its prime factors. So I'm using prime factors. And what I can do is I can do 24. I can divide this by 2. So I get root 2 times 24 divided by 2 is 12. I can break this root 12 again into, again, I can divide another root 2 out. And I get times 12 divided by 2 is 6 here. And this here would be kind of the last kind of set of numbers, because if I broke down root 6, I would simply get root 2 times root 3 here. And that doesn't really give me anything. So I'm going to leave this as root 6 here. And I know that root 2 times root 2 is root 4 times root 6. So and I know the square root of 4 is simply just 2. So I have 2 times root 6, which is simply just 2 root 6. And this here is the square root of 24. And as you can see, this solution here is correct. So solution is correct. Go to analysis. And then finally, I think this here is the last question. How do you find the measure of the interior angles of a regular polygon? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, this here's number 9. So here's my last question of the day. So I want the measure of each interior angle of a regular polygon. So if we want to figure out the interior angles of a polygon, what we have to know is we're actually given some equation. We're given an equation to calculate this. And the equation is actually given in our solution here, which is actually really nice here. So it's 180. So it says you can say the measure of each interior angle. So I can say interior angles. Angles is going to equal 180 times n minus 2 divided by n. And what is n here? Well, n here is just simply the number of sides. In polygon. So let's put this into practice. So let's see if what if I had a triangle? So each interior angles, if they're assuming we're equivalent, let's see the number of interior angles in a triangle. So therefore, so let me say in a triangle, and this is my example, therefore interior angles are going to be 180. In a triangle, I have 3 sides, right? So I'm going to say 3 here is my n here, minus 2 divided by 3. So this is 100 times 3 minus 2 is simply just 1 divided by 3. So I have 180 divided by 3, which is going to equal 60 degrees. And this is right? In a triangle, I have, if I were to draw a triangle for you, I'm going to have this here is 60 degrees, this guy here is 60 degrees, this guy here would be a 60 degrees for a total of 180 degrees. And this here is how do you find the measure of each interior angle of a regular polygon. I'm going to emphasize regular polygon because regular polygons has the same, the angles of the interior angles are all the same number here. So this is just an example for us as well. So this here is, so basically this formula helps us calculate the measure of each interior angle of only in a regular polygon. If it was an irregular polygon, we cannot use this formula because the angles are all different in an irregular polygon. This here assumes that my interior angles are all the same in a regular polygon. So again, they're all, for example, a triangle is all 60 degrees. In a square, it would be all 90 degrees, and so on and so forth. And this here is the correct solution. So they wrote this formula is good, and they took it even further, and they wrote the sum of all interior angles, which is great. And they even took an example of a hexagon where n equals 6. So you subbed in n equals 6 here. So 6 minus 2, 180 times 6 minus 2 divided by 6, which is 180 times 4. 6 minus 2 is 4. And then you would get 30 times 4 here, which is 120. So whatever 180 times 4 here is 720 divided by 6 would give me 120. So therefore, each interior angle is 120 degrees. So the solution here is correct. Good analysis as well. So that brings us to my 10th question of the day. Again, thank you so much for tuning in to our channel. Again, my name is Joey. I stream math on Monday, Wednesdays, and Fridays, and I stream chemistry on Tuesdays and Thursdays. So you come check me out then. If you like these videos, again, definitely give the OneClass YouTube channel a subscribe and a like, and you can follow along and get notified whenever we have new videos up. Again, thank you so much for watching. Stay safe, stay healthy, and have a great day. Take care.